The acetoacetic ester synthesis is used to convert acetoacetic ester, which is this molecule right here, into a methyl ketone. In this reaction, the ketone has to have a methyl group on one side that's coming from the acetoacetic ester molecule, and then we're able to add up to 2 alkyl groups on the other side of the ketone. The 2 alkyl groups could be different from each other, or they could be identical. If you want to add 2 alkyl groups, you need to use all 5 of the steps that I'm showing here. If you only want to add 1 alkyl group, for example, if we didn't want to add this alkyl group here, then you do not need to use the step number 3 and step number 4. This could just be a 3-step process. I'm going to show you the mechanism for this reaction. It is almost identical to the mechanism for the malonic ester synthesis. So I'm going to move a little bit faster through this mechanism than I did for the malonic ester synthesis. If any of the steps, if it feels like I'm going too fast, just back up to the previous video and watch that malonic ester synthesis reaction, and that should make things make a little bit more sense. In the first step, we're going to use our ethoxide ion to deprotonate the alpha carbon that's in between the 2 carbonyl groups, because being in between the 2 carbonyl groups makes it the most acidic site in the molecule. And I'm not going to draw the second hydrogen. It's still there. I'm just choosing to not draw it. Once we have formed the enolate, then we're going to do an SN2 reaction with alkyl halide of our choice. So right now we're on step 2. This is, as I said, this is an SN2 reaction, so you want to make sure that whatever alkyl halide you're using here, it is appropriate for SN2, specifically nothing tertiary. And this is going to put the first alkyl group on the molecule. Now, I'm not going to put a second alkyl group here, but if you did want to put a second alkyl group on this molecule, you would just use another round of ethoxide to deprotonate the second alpha hydrogen, make an enolate again, and then repeat this SN2 process to get your second alkyl group on there. Once you have the correct number of alkyl groups positioned on there, then you come in with the H3O plus molecule. This is the last step of the reaction. This acid will hydrolyze the ester functional group of this molecule. So it's going to convert it from an ester to a carboxylic acid. I'm not going to show the mechanism for that. That's a mechanism that you learned when you were studying carboxylic acid derivatives. This particular molecule, we want to, it's going to undergo like a little bit of a rearrangement, and I'm going to redraw. So that's what I'm doing here with these little dashy arrows, not meant to indicate a reaction arrow, but just that I'm redrawing the molecule. And if you watched the malonic ester reaction, you know what's about to happen here. So I'm just turning around the carboxylic acid group. Instead of drawing the carbonyl up, I'm drawing it down to the left. And the OH group, I'm drawing up, and I'm also expanding the OH bond. What we're going to do next is kind of like a Diels-Alder type reaction. We're going to take the carbon-oxygen double bond, and we're just going to start shifting all of the electrons around the same way we'd shift our electrons around for Diels-Alder. So when we do this, the product that we get, I'm going to redraw this as carefully as I can. I've already made a mistake. So I think I'm going to start here. So this becomes a carbon-carbon double bond. We do still have a methyl group right here. This becomes a carbon-oxygen single bond, and we also still have this methyl group out here. We have created a single bond between the oxygen and the hydrogen, and we have broke this oxygen-hydrogen bond. This has become a carbon-oxygen double bond. This double bond is still there. This bond is broken. This is the CO2 molecule. This is a gas, so this just bubbles itself right up out of solution. And this is the actual product that we've made. Now I'm going to redraw this thing again because it looks kind of funny the way that I've drawn it there. This is an enol. And the enol undergoes, as you know, tautomerization to make a ketone. And so there is the product for this reaction. It almost seems a little bit like magic, but we have created a ketone with a methyl group. That's the alkyl group that we added to the alpha carbon.